Hi, I'm Hui Ye from City University of Hong Kong. I'm glad to share a paper here, ProGesAR, mobile AR prototyping for proxemic and gestural interactions with real-world IoT enhanced spaces. This work was done with Professor Hongbo Fu. Real-world IoT enhanced spaces usually involves diverse proxemic and gestural interactions. These interactions are important to increase the life convenience in people's daily life. Designing such interactions is an emerging need in IoT industries. To prototype such interactions, designers usually draw 2D storyboards, make videos using mockup systems, and doing programming to specify interactive behaviors. To avoid using complex hardware setup and coding skills, some techniques has explored to use the miniature or the virtual scenes to simulate the real-world environments. And usually they are using the familiar working schemes of designers. But the lack of connection between the created prototypes and the real things make it difficult to prototype physical interactions happening in the real-world environments. Recently, augmented reality has been used to design AR prototyping tools and authoring tools, but they are not for prototyping full-body proxemic and gestural interactions in real-world spaces. So our goal is to explore a novel tool for prototyping such interactions in the real-world space using mobile AR to make the prototyping happen in situ easily by designers. Since there is no existing tools or works about prototyping such interactions, we first need to figure out the existing design challenges. So we conducted depth interviews with 5 design experts by discussing with them about the prototyping tools and the workflows, their common challenges and problems during prototyping, and their expected features of a novel prototyping tool. So from the interview, we distilled 5 main issues. First is that all of the interviewees believe that there is a huge gap between the 2D storyboard and 3D real scenes. So the lack of physicality make them difficult to imagine how the 2D scenes will correspond to the 3D real scenes. And second, all of the participants think that they had usually used the multiple perspectives in their prototyping workflow, but they find it difficult to switch between different tools to use multiple viewpoints. Especially they thought that first-person view and third-person view are both necessary for testing, viewing, and examining the created prototype results, because the combination of these 2 viewpoints will give them a global expression and will let them to experience from a potential user's view. And then they think they expected a tool to let them repetitively retest and redesign their design ideas. Then they also think they expected a tool to help them create interactive prototypes with a low cost. Finally, regarding prototyping device, they thought different mobile devices have their pros and cons. They thought mobile phones and tablets are more suitable for rapid prototyping in their daily lives. Based on the results, we distilled 4 design considerations for a novel prototyping tool. First, the tool should be used for prototyping for real-world things and real users institute in mobile AR. Second, it should support first-person view authoring and both first and third-person view testing. Third, it should support retest and redesign easily. Finally, it should support to create interactive prototypes at a low cost. Based on the 4 design considerations, we designed and developed ProGesAR, a mobile AR tool for prototyping proxemic and gestural interactions in real-world spaces. It supports 4 spatial events, and they are represented by 2 kinds of event proxies in our system. And 2 testing views are supported in ProGesAR. Now we will use an example to illustrate how ProGesAR works. In general, designers can follow 4 steps to prototype their desired results. First, they created the Wi-Fi asset from the asset set and put it in the desired location. Then assign a peer effect to it. Then create a bulb asset from the asset set with a brighten effect. Then the designer creates a music asset to the scene with a play effect. Then the designer creates a location-independent proxy and input a threshold for specifying a distance event. Then the designer creates a location-dependent proxy and select the gesture button, sit button to create a sit event and create an orientation event. After that, the designer first select the swell proxy and the appear effect of the Wi-Fi asset and map it. Then create a mapping between the location plus sit plus orientation event to the play effect of the music asset and the brightening effect of the bulb. Then move to the testing mode. The designer walks towards the sofa and the Wi-Fi asset appears. When she sits down on the sofa with facing forward, the bulb effect is bright. The bulb asset is brightened and the music is playing. And she asks another test subject to enter the AR view for testing the created prototypes. Our system is implemented on Apple AR Kit, and we train SVM classifiers to detect the different events. Please refer to our paper for more details. And here is another result created by ProGesAR. So we propose ProGesAR, a mobile AR prototyping tool for proxemic and gestural interactions in real-world IoT-enhanced spaces. If you have any questions, please feel free to contact us. Thank you.